Hi everyone! Welcome back to integralcalc.com. Today we're going to be talking about how to find the equation of a line. And in this particular example we're given two pieces of information about the line. One is that it passes through the point 3, -5, and the other is that it's horizontal. It's a completely horizontal line. So I'm going to use the slope-intercept form of the equation of a line to find this equation. You can also use point-slope form. It's personal preference because either way works just fine. I like the slope-intercept form. I think it's easier to use. So we're going to use y equals mx plus b, where m is the slope of the line and b is where it intersects the y-axis, or where it crosses the y-axis. So everything else about the equation is fairly easy, but m is the slope, and to find the slope we need this equation here, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And where we get these 4 points here are from 2 points on the line, one being x sub 1, y sub 1, the other being x sub 2, y sub 2. So we're only given 1 point and then the information that it's horizontal. So in order to find m, we're going to need to find another point on the line. I think the easiest way in this particular case, since we don't have another point, is to plot the point 3, -5 and then draw a horizontal line through that point. So when we do that, you can see here that we've plotted the point 3, which is about here, 3, -5 is right here, and then we draw a completely horizontal line, and that'll give us a good visual about other points on our line, so we can pick a second point and use it to find m, the slope of the equation. So we can see we have 3, -5 here. If we draw this completely horizontal line, you can see that y, the y-coordinate, is going to be -5 everywhere. So we can use the point 0, -5, where it intersects the y-axis, as our second point. So that's what we'll do. So our first point will be 3, -5, so x sub 1, y sub 1 will be 3, -5, and x sub 2, y sub 2 will be 0, -5. So when we plug in those values to our y equals mx plus b equation, we plug in those values for m. Again, see we have here, we have x sub 1, y sub 1, which will be the point that we found using the graph. So that's 0, -5, right here where it intersects the y-axis. And for x sub 2, y sub 2, we'll use our original point 3, -5, and we have here 3 and -5. So we plug in those 4 values. It doesn't matter whether you assign which point 3, -5 or 0, -5 you assign to x sub 1, y sub 1, and which you assign to x sub 2, y sub 2. You can do it either way as long as you keep the points consistent. So as long as 0 and -5 both go with x sub 2, y sub 2, or x sub 1, y sub 1, etc. So we plugged in these points here, and when we simplify the slope and plug in one of our points, we can pick either one, but once we plug in those numbers for the slope, we'll pick one point and plug in for x and y. So we'll plug in -5 for y and 3 for x. So you can see -5 for y here and 3 for x. And we've simplified our slope equation. So -5 minus -5 is actually a -5 plus 5. So we get 0 in the numerator, and then 3 minus 0 in the denominator. So obviously the slope here, this is m, is 0, which makes sense because our line is completely horizontal and the slope of any horizontal line is 0. But when we simplify this, we can see 0 over 3 is going to be 0. Multiply that by 3, we still get 0. So we end up with -5 equals b. So if we plug that back into our slope-intercept equation, remember that we said that m was 0. We found the slope to be 0 right here. So that means we'll get y equals 0x plus b. We found that b was equal to -5, so our final equation for this line is y equals -5. The whole x term here with the slope drops away since the slope is 0. And you should recognize this as the equation of a horizontal line because it's just the line where y equals -5 all the time. And you can see that that's what our line looks like from the graph here. So I hope that video helps you guys, and I will see you in the next one. Bye!